For the next problem in our sequence on factoring, we're going to try to work with the difference of squares formula. This is a very common factoring type where a squared minus b squared is equal to a plus b, a minus b. The practical use of this is when we're given a problem like this, we just take the square root, which is a perfect, if it's a perfect square that is, take the square root and add it to the square root, then we do the same but with opposite sign. So for this problem, which is essentially the simplest difference of squares that we can get, we're going to have the square root of x squared, which is x, plus the square root of 1, which is 1, and the square root of x, which is x, minus the square root of 1, which is 1. That's completely factored. It can get a little trickier. For example, in this problem, I have to factor it. So 16 is a perfect square, x to the fourth is a perfect square, 81 is a perfect square, as well as y to the fourth. So each term is going to consist of the square root of the original. So the square root of 16x to the fourth is 4x squared, plus the square root of this term, which is 9y squared. The second binomial is the same exact thing, but with opposite sign. This is now prime. There is nothing that I can factor out of this. But if you notice, 4x squared, 9, and y squared, those are also perfect squares, so we must continue. So this prime term, 4x squared plus 9y squared, stays the same. But now we take the square root of 4x squared, which is 2x, and add it to the square root of 9y squared, which is 3y. We repeat the process with a subtraction. Being binomials of lowest degree, these two are prime, and we've already declared this prime, so we have a completely prime statement. That's the difference of squares.